Hello everyone. Welcome to First Online University, a global platform for all your education and growth related needs. In this lecture, we are going to continue with aromatic hydrocarbons and we will be focusing on the nomenclature and the rules for nomenclature, that is giving names to these aromatic compounds. Before we begin, a piece of information for you. You can use the coupon codes Mission JEE or Mission NEET while you enroll at First Online University for Mission JEE or NEET. Now let us talk about the nomenclature of aromatic compounds, and we are going to divide this nomenclature into various parts. The first part includes an introduction to what nomenclature of aromatic compounds basically means. When we talk about monosubstituted benzene, now substituted benzene means it has a substituent. Mono means it has only one substituent present on the benzene ring. So the first rule for naming the monosubstituted benzene ring is that we are going to name it by placing the name of the substituent as a prefix to the name of benzene. So when we have benzene, we put a prefix to it and then we say that this is going to be the name of that compound. So benzene is going to be my parent compound. The substituent that is present will be given as the prefix. And since there is only one substituent present, we need not give the numbers. So here, when my hydrogen, one of the hydrogen in the benzene ring is going to be replaced by some substituent, say chlorine, we call it as chloro, that is the prefix, and benzene, that is the parent compound. So chlorobenzene is the nomenclature of this monosubstituted benzene ring. Again, if I have, suppose, nitro group, I call it as nitrobenzene. If I have bromo present, I call it bromobenzene. Rule number 2. The name of benzene derivatives are going to be known by some common names also, and these common names are accepted by IUPAC. So even if like you are asked to give the IUPAC name of this particular benzene compound and you are not given any option and there is one option called none of the above, you do not have to go with none of the above. You have to go with the common name also because those common names are accepted by IUPAC. So if we look at where the OH is going to replace hydrogen, although ideally it should be hydroxybenzene, but its common name is phenol. Again, we have another example where when where the hydrogen when replaced by a CH3 group, that is a methyl group, it should ideally be methyl benzene going by the IUPAC nomenclature rules, but it is called toluene. Another example is where when hydrogen is replaced by NH2, it should be called aminobenzene, but it is called aniline. And these common names are accepted by IUPAC nomenclature. You should be knowing the structure and the names because many a times in questions you will not be given hydroxybenzene, you will not be given aminobenzene, you will not be given methylbenzene, you will be given these names and you should be able to identify which structure it corresponds to. Similarly, if I have, say, carboxylic acid group replacing benzene, it is called benzoic acid. Sorry, replacing the hydrogen of benzene, it is called benzoic acid. Rule number 3. If the alkyl substituent is larger than the benzene ring, say benzene ring has 6 carbon atoms and the alkyl substituent say has 7 carbon atoms, then benzene is going to become the substituent and that alkyl substituent is now going to be my parent chain. Benzene, when it comes as a prefix or as a substituent, will come as a prefix. We call it phenyl. Okay, so if I have this benzene ring getting classified into, we call it as phenyl. If we have C6H5, that is one of the hydrogen atoms only replaced, or phenyl can further be divided into containing alkyl group, which has 6 carbon atoms, or it can be linked to some functional group. Similarly, benzyl is where you have C6H5 and a CH2 group present on replacing one of the hydrogen atoms of benzene. And onto the CH2 group, there is a substituent present. Then we call it as benzyl. So you should be able to understand the difference between when we have to call benzene as a prefix in the form of prefix as phenyl, and when is it do we call it as benzyl. So remember, when one of the hydrogen atoms is going to be directly replaced by this alkyl chain, which is longer than the benzene ring, we call it as phenyl. And when there is a CH2 group which is present next to benzene, which has a long parent chain, then we call it as benzyl. For example, if we look at the structure, now here, since benzene ring, one of the hydrogens of benzene ring is directly replaced by a longer alkyl chain, which is a larger alkyl substituent, benzene here is going to become a substituent, and this longer chain, which contains 7 carbon atoms, is going to be my parent chain, heptane. So here, benzene will get will get the prefix phenyl. Okay, so we call it as 2-phenyl heptane. So here a long process has been shown to you, but this has already been discussed in the previous lectures when we were talking about the nomenclature also, and when we have discussed the rules of nomenclature extensively. So I'll not be doing that every time, but here just to revise and to make you understand, this is how we number the chains from the carbon atom where the substituent is going to get the lowest possible number. That is the lowest locant rule. And then this substituent, which is phenyl, will be given the name by 2-phenyl heptane. Okay. Let us look at another example. Now here, if you see that the substituent is large, maybe it does not contain more than the number of carbon atoms that are present in benzene ring, but again it is a very large substituent, and calling it a substituent will be wrong here. Therefore we call benzene as the substituent, and this is going to be my parent chain. So this is the parent chain here, which contains carbon atoms number 4 carbon atoms. So it's going to be the root name, or the parent name is going to be butane here. If we start numbering, now the question is, from where do we start numbering? If we start numbering from the side of nitro group, we have 1, 2, 3, 4. And if we start numbering from the other side, where we have CH3 getting the number 1, then 2 benzene, 3 CH2, 4 CH2 containing nitro, then we'll have substituents on 2 and 4. In this case, we have substituents on 1 and 3, and therefore we choose where we have substituents on 1 and 3. So it's going to be 1 nitro, 3 phenyl, then butane. Okay. Now let us look at this example. Now here, if you carefully see, we have an OH group which is attached to not benzene directly. So it's not phenol. Remember, it is not phenol. We have a CH2 group which is attached to benzene, and that CH2 group has OH. So we call it as, so here we have functional group present. So it is an alcohol. It is benzyl alcohol. Remember this structure, because many a times in the question you will be simply given the name benzyl alcohol and then you will not remember the structure. So remember these names, common names, whatever are being given in this particular lecture are extremely important in terms of, because when you will be given a long question and somewhere in between the word comes benzyl alcohol, when you don't at all understand the meaning of benzyl alcohol, how will you proceed with the question further? So all these common names should be very, very, very clear to you, and you should remember them along with the structures. The next thing is where we have, so this is going to be another example where we have a Cl group which is attached to one of these CH2, which is a substituent on the benzene ring. So here my parent chain is propane, which contains chloro and phenyl. Now here propane is my parent compound, so that is going to be the root name. First carbon contains chloro, the third carbon contains phenyl substituent. So it's going to be 1 chloro, 3 phenyl propane. Okay. Now, as I told you that I have divided the nomenclature of aromatic compounds into various parts. The first part is over, where we talked about monosubstituted benzene rings, the different kinds of substituents that are present. Now, the second part, when we talk of, has the nomenclature of di-substituted benzenes. That is when there are two different substituents, or maybe the two same substituents also present on the benzene ring. So if we look at this, benzene in which two of the hydrogen atoms are going to be replaced by any alkyl group or a functional group is going to be called a di-substituted benzene. So here, there are going to be different isomers of di-substituted benzene, where we can have the two substituents present at ortho position to each other, or meta to each other, or para to each other. So in that case, we have such examples. So if there is a functional group here and then there is a functional group at the first and the second position, we call it as ortho position. Okay. When we have this, so where this number 1 is marked, this is known as my apical position. Okay. The second position, which is just adjacent to the first position, containing another functional group, it's going to be called as the ortho position. Similarly, if I have 1, 3, it is going to be meta position. 1, 4 is going to be para position. Okay. So here, let us have a look at the rules now. Rule number 1 states that if there are same substituents present on either 1 and 2, 1 and 3, 1 or 1 and 4, then we will use the prefix di before the name of the substituent itself. So for instance, I have two chloro groups that are attached at ortho position to each other. So it's going to be an example of dichlorobenzene, because 1 and 2 positions are ortho. So we call it as ortho dichlorobenzene. Or you can also call it as 1,2 dichlorobenzene. The next example is where we have the same substituent present at 1 and 3 positions. So we call it as meta-dinitrobenzene or 1, 3 dinitrobenzene. Rule number 2 states that for different substituents, they can be numbered and entered in the alphabetical order. Okay, so depending upon what is the name of the substituent, we will be giving the nomenclature, the substituents. Okay, so number is not going to be different, but while naming, we will be putting in the alphabetical order. So if we talk about 1 and 4 substituted, so where are we going to start with? Iodo or bromo? So let us start with iodo, and we have the incorrect way of numbering here because we have to go in the alphabetical order, because these 1 and 4 positions are the same, and wherever, because it's a cyclic structure, so it does not really matter where you start from. So you have to start from bromo, then you have to move on to iodo. So it's going to be 1 bromo, 4 iodo, benzene. Okay, or we call it as para bromo iodo benzene. Now, when we have bromo written first, that means at the para position we have bromo, and then we have iodo at the para position to bromo. Now, another example is where you have chloro and nitro present. Now, as we see, chloro starts from C, nitro starts from N, and since C appears first in the alphabetical series before N, therefore, we will start the numbering from chloro. So this is the incorrect way of numbering. We start from chloro, 1, 2, 3, move to nitro. So it's going to be 1 chloro, 3 nitro benzene, or we call it as metachloronitrobenzene. So any way of naming, whether in the brackets or in the pink color, is correct. Rule number 3 is if any of the two groups is to be given a special name. So if one of these two groups is going to give a special name to the molecule, for example, if there's an OH group, it's going to be called phenol. If there is a CH3 group, it's going to be called toluene. So then the compound will be named as a derivative of that special compound. So we will call the other substituent as a prefix, and then we will not have to name the second substituent. Okay, we will combine that substituent with benzene and give the special name. Let us have a look at the example. So we know that when NH2 group is attached to benzene, we call it as aniline. So we will not treat NH2 as a different substituent and start naming it as aminochlorobenzene. We will simply say it's going to be chloroaniline. So it's going to be 2-chloroaniline or orthochloroaniline. I hope this is clear to you. Now the rule number 3 also states that if again there is a special name to be given, then the compound is going to be named as the derivative of the special compound. So we know that CH3 when attached to benzene ring, the special name that is given is toluene. So here nitro will be the only group that will be treated as a substituent. We will, since we are now here, the numbering irrespective of what the alphabetical order is, will start from that substituent which is giving a special name to benzene ring. So since here CH3 is giving a special name to benzene ring called toluene, we will start the numbering from CH3 group only. Because although this is called methyl, if there would have been a chloro group also present, we would not have started the numbering from chloro. Remember, this rule is very, very important. I'll repeat. Whatever substituent is giving a special name to benzene ring, we will start the numbering from that substituent, irrespective of the fact whether it comes before or after in the alphabetical series as compared to the other substituent present. So here it's going to be 3-nitro or meta-nitro-toluene. Another example is, now here we know that when OH group is attached to benzene ring, so why I told you that remembering the common names is important, because here it's going to be of use. You should be knowing when OH is attached to benzene ring, we do not call it as hydroxybenzene, we call it as phenol. And since bromo is present at the 4th position with respect to OH group, we call it as 4-bromo or para-bromo phenol. Okay. Now, rule number 4 says that if, again, the special name is to be given to the compound, then the special group is considered in position number 1, as I've already told you. So this is rule number 4, whether it is di-substituted benzene or tri-substituted benzene. So we know that NH2 when attached to the benzene ring will get aniline, but we also know that CH3 group if attached to the benzene ring gets the name toluene. So now there is a confusion as to what to go with, whether we call this aniline or we call this as toluene. So here we start from NH2. Now 1 plus 2. So here, if this is the naming that we get at 5th position, then at 6th position. So if we start numbering from this side, starting from NH2, moving back to this CH3 group, then here we see that we will have to satisfy the lowest locant rule. Okay, 1 plus at the 5th position 5, at the 6th position 6. So 1 plus 5 plus 6 is 12. Now this is not going to be the correct order of numbering. So let us start with 1, CH3 getting 2, and then ethyl getting 3, 4, 5, 6. So 1 plus 2 plus 3 is equals to 6. So this is the lowest combination which is possible in these 3 substituents. So here we take aniline as the parent compound and 3-ethyl 2-methyl. Remember, we will do the naming in the alphabetical order irrespective of what the number is given to the substituent. So although ethyl here has a 3 number and methyl has a 2 number, as I've already told you, we could not have given ethyl a number lower than methyl because that would have violated the lowest locant rule. Therefore, we had to go in this order of numbering methyl first as compared to ethyl. So it is violating maybe one of the rules where the substituent which comes in the which comes first in the alphabetical order should be numbered lower, that rule is violated because we have to follow the basic and first foremost rule of the lowest locant rule. Therefore, we call it, but while naming, we will take care of the alphabetical order. So it is 3-ethyl 2-methyl aniline. If we have this compound, we know we can call it as phenol. So let us start numbering from OH because we are calling it as phenol. So the substituent which is giving it a special name, we will start numbering from that substituent only. So OH gets number 1 followed by Cl. So if we are okay, starting from the other side, then we see that the overall turns out to be 11, which is highest combination. So therefore, this is not the correct order. If we start in the other way and we get the total as 1 plus 2 plus 4, which is 7, that is the lowest combination possible. So we call it as 2-chloro, 4-nitro, phenol. Again, keeping in mind the alphabetical order. So the lowest sum rule or lowest locant rule must be followed. Now, rule number 5, lastly, is that if there are more than 2 groups that are attached to the direction of numbering, then we should always prefer to give the lowest combination of numbers. For instance, if we have like 3 bromo groups that are attached, we start numbering from 1, 2, 3, 4, 5, 6. So here if we see overall the highest combination comes out, which is 11. So this is not the correct way. I could have started numbering from, because here it is up to me, since all the substituents are the same, it is up to me in what order, in what way will I start and end my numbering. Now start I can do from any of the bromo substituent, but end has to be in a way that the overall combination has turned out to be the lowest possible combination. So here if I'm starting with this bromo, I will move now in the other direction, and here my total turns out to be 1 plus 2 plus 4, which is equal to 7. That is the lowest combination possible, and therefore I call it as 1, 2, 4 tribromo benzene. If I look at this, then here, remember that I'll not be using the word toluene. I can use toluene basically. So I'll start from toluene, CH3. So 1, if I move in this direction, I get the highest possible combination, and therefore I'll have to talk about moving in the other direction. Here it is going to give me the lowest combination. So it's going to be, now here the question is that can you give it the name as 2-methyl 4-bromotoluene? You can do that, but since there are two CH3 groups present, so avoid doing that and give it the name 4-bromo 1,2 dimethylbenzene. This is all about the nomenclature parts 1 and 2. You can subscribe to our YouTube channel for joining YouTube live classes for best NEET or JEE coaching. You can also download the First Online University mobile app for continuous learning through your smartphones. Keep learning with First Online University, a team of millions of learners and educators worldwide.